Okay, let's give you some more practice. So now imagine you're on Neptune. Gravity on Neptune is 11 meters per second squared. You're on a hill. I know Neptune, I think, is just a ball of gas, but imagine you're on a hill which happens to be on Neptune. So the hill here is 50 meters. You're going to fire a cannonball at 40 meters per second at an angle of 33 degrees. Find out the range. So this is the range here. Find out the range of this cannonball. Okay, so well, yeah, figure out. Try to find out the total flight time. Once you've got the total flight time, then imagine you and your dad sitting in a car traveling at whatever speed, and then times it with the flight time. But the flight time, you need to find out. You need to find out this height here, and once you've got this height, add it to this height here, and then imagine you dropping a cannonball on top of from the top of a building, and then find out how long it takes to anyway, do whatever you have to do. Find out the range. Find out the range of this cannonball. So press pause and have a go. Okay, so yeah, first thing you should do, hang on, is to break this up into its vertical and horizontal components. So vertical would be this, horizontal would be this, and then jump to your velocity time graph. So now imagine we are firing the cannonball vertically upwards, and then it's going to free fall down. Anyway, find out the time it takes to get to the maximum height. So at maximum height, the velocity would be zero. Okay. Remember, this graph just represents the vertical motion here. We are just imagining it to be firing the cannonball vertically upwards, and then it's going to free fall down to here. Okay. Anyway, so at maximum height, the velocity would be zero. So put the zero into this formula here. Okay. So this when you put zero into here, it will become this. Okay. And then blah 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 to find out t. So t, the time it takes to get to maximum height, would be this. Okay. So your velocity graph now looks like this. Velocity time graph now looks like this. You know the time it takes to get to maximum height here is given by this. And you know the area. You now need to know the actual maximum height. So we want to know the actual maximum height here, so that we can add it to this. So then we can get the overall height. Okay. So we want to know the actual maximum height. So the maximum height. Hang on, sorry. The maximum height is given by the area underneath the velocity time graph. We've worked out this length here, which is the time it takes to get to maximum height. So all we need to do is get this times this and then cut it in half. Okay, so basically this thing here is this here. You times it by this length here, which is given by this, and then you divide it by 2 because it's a triangle. Okay, so here it's really ugly. You've got a fraction within a fraction. So let's tidy up this thing here. Okay, so this top bubble here is this thing here. So at the moment you've got 40. Hang on, let me clear this up. So here you've got 40. Remember you've got this thing here multiplying a fraction, so it gets multiplied to the top. So now 40 times the 40, that gives you this. Okay, and then sine 33 is exactly the same as sine 33. It's like this is your giraffe, your elephant times your giraffe times your elephant, because the two elephants are all the same type. Well, it basically becomes this sine squared 33. Okay, so now again this thing here is this thing here. So whenever you get a fraction within a fraction, visualize it like this. So at the moment it's this thing divided by 2. So visualize it like this. That thing divided by 2. So whenever there's no need to write a fraction over a fraction. It looks so ugly. So visualize it like this. Okay. So now it's this. well, you're dividing. So really, you've got a fraction here, and then you're dividing it. So when you're dividing a fraction, well, it gets multiplied to the bottom. So everything at the top stays the same. It gets multiplied to the bottom, so it becomes 11 times 2, which is this. Okay, and then that means the maximum height is given by this. So our diagram here, this here is the actual maximum height in meters. Okay, we've just worked out the maximum height. Now we've got to add it to this. So we've got the maximum height, and then add it to this thing here. That will give us the overall height. Okay, we want to know the overall height, so that we can use the free fall formula here. So the overall height is this thing added to this thing, so that will become 71.57. So this the height of the building here. So now imagine you standing on top of a building and dropping a cannonball. How long will it take for the cannonball to reach the bottom? That will give us the flight time from here to here. Okay. So hang on. So how long will it take for the cannonball to hit the ground when we're standing on the top of a building that is 71.57 meters high? So use this formula here. Again, this should be ingrained inside your mind. Okay. So you put this into the h. So this here becomes this, and then blah 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 blah, and then t equals this. Okay, so it takes 3.61 seconds from here down to here. So looking at this here, so we've just worked out it takes 3.61 seconds to travel from here down to here. Well, from miles above, we found that the time it takes to get to maximum height is given by this, and then work it out. So basically, it takes 1.98 seconds to get to the maximum height, and then it takes another 3.61 seconds to fall back down again. So the total flight time is basically this thing add this thing here. So the total flight time will be it would be this 1.98 plus this thing here. So the total flight time is this. So it takes 5.59 seconds to travel from here down to here. Okay, it takes 5.59 seconds. So now imagine you and your dad sitting in a car now, traveling at a horizontal component of this speed per meters. Okay, meters per second. So you and your dad sit in a car traveling at this speed here. Now you know the flight time is 5.59. So basically, get the speed times the time of flight. That will give you the range. Okay, which happens to be this. Okay, so I'm just going to go all the way. I'm just going to go back to the beginning. Scroll slowly so that you can pause and read through the answer. Okay, so first break it up like this, and then jump to this. Well, basically, I'm just going to scroll through so that you can pause if you so that you can look at the whole answer. Okay. I don't know if this helps, but yeah. So I'm just scrolling through so that you can pause and read through the answer. Okay. So the final answer is this. Okay.